In this video, we're looking at friction in our AS Mechanics course. So friction is a force that's the opposite direction of the motion of the particle that we'll be looking at here. And we have two strings. So let's start marking this. We've got A and B, and we've got a tension there on both of them. We've got an angle of 25 degrees. So just checking the details and setting up the question is really what you need to do initially. So taking note of whatever mathematics we've been given and any kind of descriptions too. So it's smooth like pulley. So I've got a string between A, got a slope, and on the right hand side you'll also see we have a formula for F is equal to mu R, which is our formula for the coefficient of friction. So let's put in the forces here. We're going up the hill, so R is for our contact force. We've got friction going down, so we're going up the hill, so to speak. So now I'm going to set up this resolving forces aspect that we're used to probably. You would have studied Unit 2 and 3 for forces already, so you'll know the sine and cosine effect of that. And gravity going down here, so for B, the tension on B will be a little bit less complicated. We've less going on, so to speak. I'm going to say it's positive direction going down. And we have a mass of 2.7 G and 2.2 G. You could change that to 27 and 22 immediately if you wish. Okay, the system is released from rest. The coefficient of friction. So we need to set up this question as well as we can. And on the right hand side, as I said, you can check these details for your formula and aspects like that. We're also given a few details with time and distance, so there will be some SUVAT involved as well. And ultimately we want to find the value of mu, which is the coefficient of friction, as I said. The measure of roughness, that kind of idea. We look at resolving the forces separately for A and B. So the magnitude of the force. So we start with R. So the direction it's going is more or less, it's kind of diagonal, but you could pick up if you want in that sense. It's up to yourself for your own descriptions. Okay, 2.7 G, cosine or sine. You need to think about what you're doing here, so just think of the direction. So it's going with the angle. Along the side of the angle is cosine, as always. And we've 25 as our angle. So just pop that in your calculator. So when you do it away with the tension, so we have T, and we have another force in that same direction going the other way. We have what we consider a resolving force with sine. So we have T minus F minus 2.7 G sine 25. Again, pause the video if you're not entirely sure. Just have a quick look at how that works. They're all going in the same direction, whether it's forward or back. And of course, if it's going in the opposite direction, it'll be minus. Like the minus F there, for instance. So this is F is equal to ma we're doing. Force is equal to mass times acceleration. That's for the first particle, which was A. B, less expansive. So 2.2 G, which is the weight going, is going down, minus our tension is our force, which is equal to 2.2 A. There are two equations, it would appear. You can simplify those equations, no problem, as you go along. But I just want to show it so you can see it clearly in a lesson. And we'll have a quick look at rearranging this. So F is equal to mu R. Of course, R is our magnitude of the normal or contact force. So I'm just rearranging and just rewriting it there. So 2.7 mu, that symbol. And of course, the G cosine 25. From there, it might be a little bit tricky in terms of how to see what comes next. So just think about what you're doing. You're dealing with possibly simultaneous equations in some way. That has to be what it might be, because you've got two unknowns. You've got a T and an F. So if you rewrite it maybe, or maybe you'll see it. But you may notice with the T's, with the two T's, that they might cancel out actually. So you see it there like that. So I've replaced the F with what I just calculated on the right hand side. I just rewrite the second one here. So our equation number 2. And we'll be able now to get an equation for acceleration, let's say. So T minus T, they cancel out. And of course, if you have a quick think about your simultaneous equations rules, we had different signs, so we add them. Same sign, subtract. That's the way I remember that. And we've done all of that. Just put in your calculator and you'll get that value for acceleration. So 2.2 g minus that. Just retain the sign basically. Mu cosine 25, and of course the 4.9 will go underneath. So we're dividing both sides by 4.9 in that sense. Now that does not look very pretty, but that's what we have. Okay, so we have a value for acceleration. And going forward, just thinking about what we've done already, we've done some forces equal to mass times acceleration. We've calculated an equation for our friction, F equals mu R. We've done a simultaneous equation calculation. We've resolved the forces in two directions. So I think the only thing left is SUVAT in some way. We're given a number of details at the end in the third paragraph. Distance is 1.82. U and V. You have to think about, just go back over the paragraph previously perhaps, and you'll see that your initial velocity was 0. And time is 3 seconds. And again, just about picking your equation, one of the equations of constant acceleration, ut plus half at squared is very commonly used. Half 9 is 4/5. So divide 1.82 by 4.5, you'll get 91 over 225. That's our acceleration value. So from there, we'll substitute it back into the original equation we have on the left-hand side of the base of this calculation. And again, quite a bit of algebraic manipulation. And you can start to make those aspects of the equation easier looking, perhaps. I've just kept it the way it is so that it's very clear. So you may not have 2.2 g, you might just have 22. In this course we use g as 10. And of course for 2.7 g sine 25 you may already have that answer written out. So it doesn't look as daunting as this particular one. But for clarity, I have it all there, just to make sure. So rewrite that out, and I'm removing mu, so I'm kind of doing this all in one go. You'll see mu, I've underlined it, so 4.9 times your acceleration. So multiply both sides. And then, of course, whatever was part of mu, we'll be dividing by that. Have a quick look over this if you need to, in terms of just jumping the step of it. So 2.7 g cosine 25. And that should get you your answer. Again, do it in bits and pieces. Do it in parts if you need to. Be very careful and use your brackets as well when you're doing things on your calculator. So you'll get a 0.352. Keep in mind, there will be questions involving friction and inclined planes or slopes quite often. They're very common. And so this is a very good reminder of resolving your forces on a sloping plane, as well as the aspects of the friction involved in Unit 4.